This video is part of the series on the Control101 MATLAB toolbox. This particular one looks at the heat exchanger files. Some background then. So the community agreed on an outline structure for a Control101 course, and we wanted to develop a MATLAB toolbox to support such a course, because MATLAB supports visualization and also number crunching so that students can focus on core concepts. This particular video is going to look at the files supporting an understanding of simple heat exchanger systems. What is a heat exchanger then? Well, you can see a simple picture here which is meant to represent a heat exchanger, and you can see in the top left we've got a pipe, in the middle we've got a red line which represents the heating. Now in this case the heating is going to be provided by condensing steam, and the thickness of the line represents how much heat you are supplying. The inflow is given by this pipe in the top left, and you can see it's got a temperature T in, and the flow rate is represented by the thickness of that pipe. So a big flow rate, that pipe's thick, and a small flow rate, and that pipe will be thin. And the tank volume can also be changed. And as we've said, heating is supplied by condensing steam. Now the colour of the tank is also used to indicate temperature, so you can see dark blue is cold and bright red will be hot. So what are the core learning outcomes you might be interested in then? How fast does the temperature change when you change the temperature of the inlet or the heating? What is the steady state temperature? What is the impact of changes to the steam flow, the inlet temperature and the flow rate through the tank? What's the impact of changing the tank size? So the heat exchanger app allows users to explore these questions and check their answers accord with their expectations. Now, as always, there's a manual to support the app, which will open automatically when you run the app. The manual is in the form of a live script, and it includes things like the detailed mathematical modelling and some code to support elementary calculations. Let's do a live demonstration then. So let's bring the app in. So I've opened it for you, here it is, and you can see here I've got quite a small tank. So you can see sliders to represent the inlet temperature, the volume of the tank, the flow through the tank, the mass flow rate of the condensing steam, and we've also got some disturbances we can add here. So let's just press simulate and see what happens. So you can see here the temperature increases. We've got an inlet temperature of 10. So an initial temperature in the tank of 10, which is different from the inlet temperature here, which is 5. Now, what would happen if I make the tank bigger? Let's make it 2 and press simulate. And you can see it overlays, so you can see the impact of changing the volume in the tank. And I could make the tank even bigger. Let's make it 3. You can see the figure is making the tank bigger, and you can see how the behaviour in the tank changes. I can change things like the flow rate. So if you look at the thickness of these pipes, let's go to a flow rate of 0.1, and you can see these pipes now become much thinner. So it's going to take a lot longer for liquid to pass through the tank. So what's the impact of it taking much longer? You can see the steady state temperature is now going to be much higher, and you can see the colour in the tank has now gone this pink colour to represent that it's a lot hotter. Now clearly there's lots of other sliders here you can play with. You can play with a change in the inlet temperature. So here I've made the inlet temperature 3 degrees colder than you expect. So what happens now? Well, what you'll see is because the inlet temperature is 3 degrees colder, you settle 3 degrees colder on the outlet. And there's other things you can play with. So some conclusions. We've demonstrated how to run and use the heat exchanger app in the Control101 toolbox. And this can be deployed during lectures and student private study to help students appreciate and relate their technical and analytical learning to authentic systems. They can also be used to support pre- and post-lab activities related to heating and temperature control equipment. And the manuals provide some MATLAB code just in case you need it, so students can use this as templates for their individual investigations and modifications beyond what the apps allow.